Welcome to my YouTube channel. From this presentation onwards, you will study a new subject, that is data structure and algorithms. In this presentation, I will introduce you what data structure is and some real-life examples of data structure. So, let's get started. Before moving to the data structure, I like to introduce you what is a data. I know all of you guys know what is a data and all of you have many definitions for a data, but today I am going to explain to you dictionary explanation of the data. The quantities, characters or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical or mechanical recording media. This is what data is. We can store them, transmit them and perform operations on data. Let's see one examples here. In this example, A and B are the data. Here we can perform operations on these two A and B two data. To provide an appropriate way to structure the data, we need to know about data structure. Let's know what is a data structure. When we learn in data structures, first we should understand what is a data structure. Simply, data structure is a way of organizing and storing data in a computer. It refers to the logical or mathematical representation of data as well as the implementation in a computer program. We structure data in different ways depending on what data we have and what we want to do with it. Data structures gives us the possibility to manage large amounts of data efficiently for uses such as large databases and internet indexing services. By using this picture or diagram, we can divide data structures to two sectors, that is primitive and non-primitive. According to non-primitive, again we can divide linear and non-linear. We will talk about linear and non-linear data structures in forward lecture PDF. When we learn in data structures at very first time, we can have a doubt why we need data structures. So let's discuss why we need learn data structures. We should learn data structures because of data structures are essential in computer science and programming because they provide a foundation for writing efficient algorithms and managing data effectively. So we can understand in IT field we always use data structures in many ways. In previous slide I told you we can divide data structures to two sectors. They are primitive data structures and non-primitive data structures. And also we can divide non-primitive data structures to linear data structure and non-linear data structure. In this lesson, we are mainly focusing on linear data structures and non-linear data structures. First, we will discuss about what is a linear data structure. A linear data structure is a type of data structure that stores the data linearly or sequentially. In the linear data structure, data is arranged in such a way that one element is adjacent to its previous and the next element. It includes the data at a single level such that we can traverse all data into a single run. The implementation of the linear data structure is always easy as it stores the data linearly. The common examples of linear data types are array, stack, queue and linked list. Now we will understand what is a nonlinear data structure. In a nonlinear data structure, data is connected to its previous, next and more elements like a complex structure. In simple terms, data is not organized sequentially in such a type of data structure. It is one type of non-primitive data structure. In nonlinear data structures, data is not stored linear manner. There are multiple levels of nonlinear data structures. It is also called a multi-level data structure. It is important to note here that we can't implement nonlinear data structures as easily as linear data structures. I have mentioned some examples for nonlinear data structures. They are graphs and trees. In this slide, you can see some real-world examples for data structures. In right side, you can see some chair sets. This is an example for a stack, and also you can see a vehicle queue. It is an example for a queue. In this queue, we are called it to first in, first out. We can learn many things in one by one in forward videos. And did you know stack data structure is used in implementing redo and undo features? I think you know redo and undo features. You know this is the famous feature we use in many number of times in our application. For example, we think we are typing some Word document. When we have some error or we want to get previous changes, we can redo and undo. That is the example that is example for a stack data structure. Now we already know our lesson is data structures and algorithms. Already we talked about simply what is a data structure, and we have a small idea about data structures, some real world examples for data structures. Now we are going to discuss about algorithms. First we should know what is an algorithm. I think your O levels, A levels, if you done IT IT field, you have some idea about algorithms. It's okay. We discuss now what is an algorithm. An algorithm is a step-by-step procedure or set of instructions for solving a problem or accomplishing a task. It is sequence of well-defined computational steps that transform input data into output data. You can see a small diagram in this slide. By looking that, you can get a small idea about how connected algorithms and data structures. We will talk about forward slides. Now I will give for a easily understand, I will give you some example for algorithm. Just think a cooking recipe. A cooking recipe written on a piece of paper is an example of an algorithm where the goal is to make a certain dinner. The steps needed to make a specific dinner are described exactly. When we talk about algorithms in computer science, the step-by-step instructions are written in a program language, and instead of food ingredients, an algorithm uses data structures. Algorithms are fundamental to computer programming as they provide step-by-step instructions for executing tasks. An efficient algorithm can help us to find the solution we are looking for and to transform a slow program into a faster one. Actually, this is a very important thing that we should keep in our mind by talking about algorithms. In the context of data structures, an algorithm refers to a set of step-by-step instructions or procedures used to manipulate the data stored within. So algorithm is a set step-by-step instructions. We should type all instruction or procedures. I think you can understand all of these. In this video, we are simply talk about examples for algorithms, and in forward videos, we can learn one by one examples of algorithm. Examples for algorithms are selection sort, insertion sort, merge sort, heap sort, bubble sort, quick sort, and so many examples can have in algorithms. We can learn each one by one in forward videos. Okay guys, now we are going to discuss about and learn about data structure together with algorithms. In previous slides, we learned about what is a data structure and what is examples for a data structure. And then we learn about what is an algorithm and examples for algorithms. But we didn't learn about they are on together. If you can remember, this thing I mentioned in early. Can you remember this one? Data structures are essential ingredients in creating fast and powerful algorithms. I think you can remember. Again, I will tell you. Data structures are essential ingredients in creating fast and powerful algorithms. If we have a data structure, we can create a powerful algorithm. Can you understand? And data structure is not worth much if you cannot search through it or manipulate it efficiently using algorithms. And the algorithms are not worth much without a data structure to work on. Now we can understand about the importance of data structure together with algorithms. Actually, data structures and algorithms are very essential in many ways. Data structures and algorithms are used in virtually every software system, from operating system to web application. For example, for managing large amount of data, such as in a social network or a search engine, and for scheduling tasks to decide which task a computer should do first, for planning routes like in a GPS system to find the shortest path from A to B, for optimizing processes such as arranging tasks so they can be completed as quickly as possible. By understanding data structures and algorithms, you can decide which data structure or algorithms is better for a given situation. Make programs that run faster or use less memories. Understand how to approach complex problems and solve them in a systematic way. In this video, we got a simply idea for what is a data, what is a data structure, what is an algorithm, and how they get together. By now, in next videos, we can learn about linear data structures and nonlinear data structures one by one. Let's meet in next chapter. Our next chapter is linear data structures. So I will teach you one by one very deeply in linear data structures and examples for linear data structures and what are the method of in the data structures. So please subscribe my YouTube channel. Thank you. Let's make in next chapter linear data structures.